Okay, so this is segments and circles I'm doing real quick. And, all right, so the easiest one to do, I guess we'll knock out first, and that's when two chords intersect inside the circle. So you've got this piece right here that we'll call A, and then this piece that's B, and this that's C, and this is D. And the only thing you really have to know here is that, you know, this chord right here, this chord is cutting this segment into two different pieces. So you're multiplying those two pieces together. And that, A times B, is going to be equal to the other two, because this is cutting that one as well. C times D. So an example of that, if I draw, oh my, that's a terrible circle. Wow. Okay, that's definitely special. Okay, so this circle right here, if I have, let's say, 2 and 10 here, and then 4 here, and then an X. So to solve that, I would multiply 2 times 10 equals 4 times X. So that's going to be 20 that equals 4X. So X equals 5. Okay, so hopefully that explains that one. The next type that we have is, let me clear this one first. Okay, so I cleared that one. The next type, you're going to see two of them. There's two that are the same. Okay, you've got a secant, it looks like that. And you've got a secant tangent. Okay, there we go. Oh, that's not too bad. Alright, so we've got the secant, and tangent. And for that, you just remember that it's going to be outside times the whole, okay, equals the outside times the whole. And what that means is, if I call, I'm going to change this back to a pen instead of a highlighter. If I call this A, and this B, and this C, and this D, it's going to be A times A plus B okay, because it's the part times the whole thing, and that equals C times C plus D. So again, outside times the whole. And so I put these two together because they're kind of the same thing. Again, I'm going to call this part A, this B, and this C. So on this one, you started out the same way. It's the outside times the whole thing, and the whole thing is going to be A plus B. So that's the same. The only thing that changes is over here on this side, because your C ends at this point right here. So it is the outside. So your outside is C, and then the whole thing is still going to be C, because there isn't any part inside the circle. So that's why it's just C squared, because it's that outside times the outside again. Okay, so let's put that into practice. Let me see if I can pull a problem from the homework from tonight. I left all of my information at school, so I'm using a text that somebody sent me. Another shout out to Kiera, who sent this to me, because I knew she took a picture of my key on her way out last night, or tonight. Okay, so I've got this one. I'm going to try to do number 9. That involves some artistry on my part, so we'll see how that works out. Okay, I'm going to erase this whole thing. So I've got this circle. Okay, so I've got this circle here. Oh, that's not looking good. I still don't know where my stylus is. I suppose my dog probably ate it, which is probably not a good thing. It's probably really not good to admit that. Alright, so I've got this one, and I really can't read this, but it looks like I have a 5 and a 4 on the inside. So I've got this 5 here and a 4. And then on the other side, I've got an X and a 2X, I think. So which one's the outside? Okay, so X is on the outside, and then this one's the 2X, if you can read that. Okay, so again, it's the outside times the whole thing. So the outside piece here is 4, and the whole thing is 4 plus 5, or 9. So don't fall into the trap of saying 4 times 5. That's what everybody does. You don't want to do that. It's 4 times the entire thing. And then on the other side, it's going to be X times the whole thing, which is going to be X plus 2X. Now, in tutoring today, I had somebody who multiplied the X times the X and then multiplied it times the 2X. But let's simplify the parentheses first. That makes it a little bit easier. So 1X, because this is an implied 1 in front, 1X plus 2X is 3X. So 3X times X is 3X squared. And then 4 times 9 is 36. So you get 3x squared equals 36. So to solve that, I'm going to divide both sides by 3. I get x squared equals 12. And of course, I'm evil because I'm making you simplify radicals. So that's going to be 4 times 3. And then the 4, I'm going to go out this way, is 2 times 2. So the 2 goes on the outside, and the 3 stays behind in the inside. So that's how you solve that one. Hopefully that makes sense. Okay. And that was, I forget what problem that was. But I guess you guys can find it. It looks like that was number 9? I guess that was number 9. All right, so that's that one. I did one of the chord ones. Now, I think we did it in class, but I'll do number 14 real quick. That one's slightly different. That's another segment problem, but it has to do with angles, and we talked about how when you have, clearing this, clear all drawings, clear. So here I've got this beautiful circle, and I've got this this tangent that's coming through here. And I've got my beautiful little center here and a radius that comes down and intersects at the point of tangency. So, of course, this is not going to be exact because I'm not very good at drawing, but this is a right triangle because a tangent and a radius, that's an and symbol. Okay, they're perpendicular. So really important that you know that for tomorrow's quiz and especially for the test. And really it's important that you retain that for the ACT and SAT because, believe it or not, circles are on there, and that's something that, anytime we can put Pythagorean theorem on something, we're going to do it. So the problem that I gave you was, let's see here. I keep having to flip back to my phone here and look. Yeah, so I tell you that HK is 5 and AW is 15. Oh, yeah. And it's totally not drawn to scale at all. This one right here is 5, and this little piece right here is 15, and you're looking for this one here. That's supposed to be a question mark. That's pitiful. We'll just make that X. Okay, so the first thing it's testing you is to see if you recognize that this beautiful little radius here is going to be congruent to this radius here. So for you to be able to solve this, you have to recognize that this is 5 here, that this is a 90-degree angle, because of course I'm not going to put that on there, and that if this is 5 down here on this side, that it would also be 5 here because those are both radii, which is of course the plural of radius. So the whole side length here is 20. And then you just do Pythagorean theorem. So you've got 20 squared minus 5 squared. Now you guys are going to want a calculator tomorrow. And that calculator betrays you in a way because you want to put this in the calculator and then you get this decimal and you don't know how to simplify it. So just don't use the calculator except to type in 20 squared and 5 squared. And then this 375 is what you simplify. And I think I did it in class, but I might not have. I don't remember. I don't know. It's 25 times 15. That's a multiplication symbol. And this is 5 times 5. And this is 5 times 3. And so I've got these two 5s. So the 5 goes on the outside. And then you've got this 5 and 3 left behind that you multiply back together. So the answer is 5 square root 15. So that's the answer to that one. Okay. I'm trying to think what else I need to do because my brain isn't functioning here. Let's see here. So here's another pretty circle. Oh, I know. All right. So I'm going to make this pretty inscribed circle inside this triangle. That's not too bad. And erase this extra stuff here. Okay, that is truly special. So on this one, I'm just going to make up stuff. I don't even know what the numbers are on your problems. But this is the ice cream cone theorem. So I say cover up the extra parts and just look, if I look at this is my circle, and I just look at this right here, that looks like an ice cream cone. So anytime you see an ice cream cone, you know that this segment is going to be congruent to this segment. So if this is 4, then this is 4. And if I tell you that, I'm going to change to a different color. If I tell you that, all right, here we've got this other sad little ice cream cone here. If I tell you that this is 3, that means this is 3. And then I've got one more ice cream cone. And this is a question on your test and on your quiz. Well, on your quiz anyway. If this is 7, then this is 7. So if I was asking you for the perimeter, I would just add all those up. So that's what? 14 plus 6 plus 8. That's 14 plus 14, which is going to be 28. If I did my math right, which there's no telling because it's late and I have no brain. Okay, I think that covers everything. If there's any other questions that you guys have, you just need to come see me in tutoring, and hopefully I'll get there on time, but never know with my crazy daughter. One of the things that's kind of a problem that students struggle with is knowing when you're looking for a segment and when you're looking for an angle. So when you're looking for an angle, watch to see that your X that you have in the picture, if it has this little degree symbol, that's not to the 0 power. That means degrees. So X degrees. If you see that, that means you're looking for an angle. And if you see something like this that says X, that means you're looking for a segment. So hopefully that helps. I don't know. Anyway, that's all I got. If you have any other questions, email me. All right, thanks.